Fourth problem here tells us a cable news network estimates that when choosing to visit their mother's family or father's family for Thanksgiving, adult children choose their father's family 41% of the time. The statistics student thinks that this is incorrect and wants to test whether this proportion is different from 0.41. He asks 105 students who are making this choice for Thanksgiving and finds 37 are visiting their father's family. Conduct a test of hypothesis to see if the proportion is different from 0.41. Use a level of significance of 0.01. So first thing we need to do is set up our null and alternative. Here we don't know whether we're testing if it's going to be more than 41% or less. We're just testing if it's different from. That's why our alternative should be based on a not equal to test. So p is not equal to 0.41 is my alternative. That means my null has to be p does equal 0.41. Now that we have a null and alternative, we want to pick out the other key information here. He asks 105 students, that's my n or my sample size. Of them, 37 are visiting their father's family, that's my x, 37. I can use these two to calculate my p hat of 37 over 105. When I put that into my calculator, 37 divided by 105 gives me 0.352, which I'm going to call 0.35. Last thing I need to pull out is the level of confidence. In this case, they already told me the level of significance. If it's given to me as level of significance instead of confidence, that just is my alpha. I don't have to do any 1 minus. Now that I've got everything I need, I can calculate my z-score as the sample value, 0.35, minus the value under the null and alternative, 0.41, over the root of that same 0.41 from the null and alternative, 1 minus 0.41, divided by n, which in this case is 105. Again, I have to be careful putting everything in. I'm going to put it in as parentheses, 0.35 minus 0.41, n parentheses divided by new parentheses, the root of, parentheses 0.41, n parentheses, new parentheses, 1 minus 0.41, n parentheses divided by 105, all still under the root, n parentheses. When I do that, I get negative 1.250, which is just negative 1.25. Now that I have my test statistic, I need to find my test probability. So I go to the negative side of my table. I look up negative 1.25, and I get a p-value of 0.1056. This is when I look back to the alternative hypothesis. If it had been less than, this would be the p-value of the test. If it had been greater than, I'd do 1 minus this to do the p-value of the test. Instead, I have the most difficult one, not equal to. When you add not equal to, you're always going to double something. You just have to recognize, am I on the right or left side of the table to know what you're going to double. If you have a positive p-value, you're on the right side of the table. You do 1 minus the table value and then double it. In this case, we have a negative z-score, so we're on the left side of the table. We just take the table value and double it. So 2 times 0.1056 is going to get me to 0.2112. That is my test probability, 0.2112, which needs to be compared to alpha, 0.01. In this case, the test probability is greater than alpha, which means my conclusion is fail to reject.